and this is my Physics 2212 Lab 2, the magnetic field of permanent dipole magnets. In the introduction, the purpose of this lab was to experimentally determine the magnetic dipole moment of a given bar magnet and to create a computation model for this magnet with that value. Models used are the Biot-Savart law, magnetic dipoles on and off axis, and that the second was really the most important one here, or the one that was used most computationally. The results found that the strength of the magnetic field of the dipole is proportional to the inverse of the cube between the observation location and that magnetic dipole. And this was confirmed based on what we've learned prior. I know in my experiment it came out to be around 2.9, which is close enough to 3 due to some errors. Mu of bar magnet I got was 0.0905, and that would be amperes meters squared. And experimentally, I determined the magnetic field to be 4 times 10 to the minus 5 Teslas, at 45 degrees north of east. And computationally, the same concept was around 3.73 times 10 to the minus 6 Teslas. My system was the magnetometer, and the surroundings were the rest of the phone, the earth, the tape measure, and the bar magnet. The physics behind this are the Biot-Savart law, of course, because we're dealing with magnetic fields. Though the magnetic dipole equations given below are derived from what's shown above, and that's what we use to determine the magnetic field at the locations on and off the axis. Experimentally, the procedure went that the phone was first aligned with Earth's magnetic north, and then to determine the location of the magnetometer in the phone, the procedure was followed via aligning things so that the X field was maximized in one spot, and then to find the different coordinate in the phone, the Y component was maximized. And then on axis, the bar magnet had to create magnetic fields of 20, 70, 120, 170, and 220 microteslas, and the distances were recorded in the x direction. And for the off axis, the bar magnet was placed so that the net electric field is 100 microteslas, and then the magnetometer is moved in a distance in the y direction equal to that of the x direction. And the magnetic field was recorded in the x, y, and z directions at that spot, 45 degrees north of east, in that specific distance. And then after all this data was collected, it was computationally used in the Excel sheet to determine, as shown here, this logarithmic scale for the on-axis, and we'll show later on some things for the off-axis. But for these calculations to determine 0.0905 amperes meters squared as the magnetic dipole moment, this was followed here. And then this is scaled logarithmically, like I said. And then for the off axis, the magnetic field was found in the x, y, and z directions, and then accounted for was the Earth's magnetic field to determine the magnetic field due just to the magnet. And then for the GlowScript code here on the left is I have my magnetic dipole moments, and then my the function that gives the magnetic field at each observation location. I should have used the dot function in GlowScript, but I didn't know it existed. And then on the right, we have at the top here the r-axis, which gave two different on-axis representations of the magnetic field, and below is 4 perpendicular observation locations. And then at the bottom, the 45-degree one, as shown here, the purple is 45, orange is on, blue is off axis, which checks out because the on axis are twice more than the off, and the 45-degree one is less than the other two. For the what if questions, if the Earth's magnetic field was not accounted for, things would be the same. Or I'm sorry, if the phone wasn't accounted or wasn't matched with the Earth's magnetic field, the results would be the same so long as the Earth's magnetic field was accounted for. If it weren't accounted for, of course, it would be different. But if things were taken into consideration component by component and subtracted off, then we'd be left with the result, magnetic field of the magnets. And if the two identical magnets, this one was pretty tricky for me because uh, I ultimately decided that instead of having the magnetic field be twice as large, it'd be the same because the magnetic dipole moments would be the same for both the magnets. And so it would just act as one magnet instead of two separate ones. But I guess it may depend on how it's oriented. I really don't know. That'd be future consideration. Ultimately, my discussion, the magnetic dipole moment was 0.0905 ampere meters square, like I said before, and that at a point on that's 45 degrees from the magnet, Experimentally, I found it to be 4 e to the minus 5 Teslas, although computationally I got 3.7 e to the minus 6, which is quite different by a factor of 10, but I guess it somewhat makes sense, and this bottom equation here was used for the closed script. Overall, my errors mostly came from the accuracy of the measurements by the phone, as well as the distances I recorded, and other magnetic fields that could have potentially acted on the system other than the magnet and the Earth. And overall, I took away that you can calculate the dipole moment when graphing distances and magnetic fields on a logarithmic scale.